Now you may have noticed that mainframe has one output, and that output has a max number of LEDs that you can connect to it. So now that max at launch is 320 LEDs, and I should explain what that max means. So that max means that you could connect 320 unique LEDs to mainframe, because each unique LED you add adds a certain amount of CPU and memory overhead. So there is a hardware and software limitation because of that. But more importantly is that this LED that we're using here, the WS2812B or the Neopixel, actually sets a limitation itself because the data format or the protocol it takes is quite slow. So that means if you want real-time performance and cool animations, a good UI, and a high data rate, that means there is going to always be a limit to the number of LEDs you could connect. I'm working on increasing that limit as much as I can, but the fact of the matter is there'll always be that limit. And I found 320 is a good enough kind of in between where you could still do some cool things with it, but also it still performs pretty well. But what I also want you to know, and what I'll be showing you in this video, is that 300 LED max is not the actual total number of LEDs you could potentially connect to the system. That just means each string you connect, you can maximum display the animations on 320 LEDs. But you can actually duplicate that string as many times as you want using splitters, and I'll be showing you what that means. There are two kinds of splitters you can make. There are splitters that are unpowered and splitters that are powered. The powered ones are a little more complicated and a topic for another video, but I'll be showing you the unpowered ones, which will kind of give you an idea of what you can do and hopefully give you ideas on the different installations you can make. Now, a bigger reason why I want to show you this is I want to actually inspire any mainframe users to think about how they could actually build their own LED installation. When you get mainframe and you get, let's say, an LED strip or a grid, you should know that you're actually not stuck to just that one LED strip or grid. By using splitters, you could actually expand your system quite a bit more, and based on how you arrange it and how you kind of play with them, you can actually get some cool effects all from just your one mainframe. Using this simple splitter and duplication process, you could actually create quite large and cool installations, like the ones you see here. And the biggest one I've done to date was 2,860 LEDs across 2 mainframes. Here I have a typical LED strip that's used by mainframe, which is the WS2812B, and it uses a standard connector like this one here. It has 3 wires, red, green, and white. Red is 5 volts, green is the data, and white is ground. And so you could also get cables like this one, which are exactly the same type here, which I use for installations as well. So now in order to actually power the LED strip, you do need these 3 connectors. All you need to do is just power it with 5 volts on red and white. And then where things get interesting is the green data signal, because coming from mainframe, it has just one of these data lines. What you can do is with a bit of DIY knowledge, you could actually basically infinitely duplicate this green data signal by using like connectors like these, wires like this, and also terminal blocks like such as this one. So here's one example of a splitter I've made here. So on this end, this is actually the input side of the splitter, where if you look at mainframe, it has this is the output end, so it actually just connects in like that easily. And then now with 2 outputs, this allows you to actually connect to 2 LED cables or 2 grids or whatever. Now this will work, but it's an example of what I call an unpowered splitter, which is different than a powered splitter, and I'll explain the difference. All right, so let's say you have one mainframe and you have 4 LED strips. Now when I say 4 LED strips, this could mean LED strips, the grids, the Christmas lights, anything. It doesn't make a difference. Let's say I want these 4 LED strips to be powered by the one mainframe. What I have in between them is a splitter. So the basic concept of a splitter is if we take the data signal from mainframe, the one output it has, and send it through this splitter, basically what it does is just duplicates this signal. So then each of the LED strips gets a sort of copy of that signal. And that means they'll all be displaying the same thing. And where the powered versus unpowered splitter comes in, it really comes down to how much power they're planning to draw. So if you are displaying these LEDs as, let's say, pure white and very bright, that's the maximum power draw. If mainframe is the only thing that's powered, that means all the power is coming from mainframe and being sent to these LEDs. If they are bright, they are drawing too much power from mainframe. So when you have this power supply being split this way, each of them doesn't get enough. And so what you'll see is that they either start to glitch or they kind of turn yellow, like, and they kind of discolor at the ends especially. So if that ends up happening to you, that's okay. Like, there's not really a huge risk. Just kind of stop running it that way, and you'll be clear that you're kind of turning them on too bright. And that's when you need a powered splitter, which I'll be talking about in a different video. Let's say the LEDs are just grids, so you don't want them to run very bright anyways. That means you don't need a powered splitter. You could just send the power from, and when I say power, I mean the red and the white lines you could send from mainframe through this splitter to each LEDs. And that's because they won't draw much power if they're not very bright and if you're not displaying them at white especially. And I've actually pushed this concept quite a bit, where the maximum I've ever done is 12 of the 256 LED grids powered by just one mainframe, with the signal and the power lines being split 12 times, and I didn't have a single problem. So you could push this concept quite a bit, and don't be afraid to kind of experiment a bit, because what will end up happening is, like I said, if the LEDs start to glitch or they turn yellow, then you know you are drawing too much power, so you could just kind of stop and take a step back. So this is one example of this concept in play here, and this is the LED cube that you guys have seen in my videos. So each side of the LED cube is, hey, get out of the video. Okay, well, okay. Yeah, are you good? No, hey, that's the camera. Oh, goodness. Okay, well, okay, let's get back to it. So, okay, where was I? Yeah, so what I have here is the 5-sided cube, and I have a 1 input to 5 output splitter inside here, which will then duplicate the signal coming from mainframe to the 5 different sides of the cube. And again, this is possible because we generally don't run the cube too bright. And if you did want to power something brighter, then this unpowered splitter I have here will not work. You need to move to a powered splitter, which I could talk about more in another video. An example of a powered splitter is actually the 4-pillar idea I've made before, and you might have seen in my videos. So what this is, it's actually powered by one mainframe, and the signal is duplicated 4 times to go to these 4 pillars. But now typically the way these pillars are used is that you want to run them at a very high brightness. So that's when we needed a powered splitter. Now, one of the interesting things about mainframe, and the reason why I want to teach you guys this side of things, is that it's actually kind of presented itself as almost like a DIY light installation controller, where now users of mainframe, not only do they have a lot of versatility on the controlling side, as in, you know, cool animations, patterns, mixing MIDI into interesting light shows, but because of the flexible LED system, you actually could customize and have a lot of versatility on the LED side itself, meaning you could actually take these LEDs and make your own light installations, which is actually a really cool concept, I believe, and a lot of the users found that interesting too. So now what I want to do is create a set of videos like this one explaining how you can do that. Now, I found a lot of mainframe users are more DIY inclined, but in case you aren't, I also don't want to limit you either. What I do want to do is show you guys how to do it, but also at the same time, I'm developing little adapters, interfaces, and even the splitters I'll be showing you in this video. I'm actually trying to make them myself, where now if you don't want to go the DIY route, you can actually just buy those splitters and then still get the same result and make your own light installations. But if you are a bit more DIY inclined, then you'll find it's actually quite easy to expand mainframe's LED system to your liking and kind of create something really cool and creative. Now, if you do want to jump in the DIY side, I should mention 2 things about power. Firstly, do not short it. Do not cross the red and the white LED cables. If that happens, you'll find that a light on the power supply would turn off, or even on mainframe would turn off. And that just means you shorted, so just kind of like unplug it and figure out where you shorted it. And through a single cable, you don't want to exceed 5 amps at 5 volts. And that's why with mainframe, I sell only 5 volt, 5 amp power supplies, so you don't have to worry about that. Because I found once you go beyond 5 amps, the cables and connectors start to get a bit warm, which is not a good thing. If you do have a larger setup, more LEDs, and you need more than 5 amps, that's where the power system becomes a bit more complex, and that's worth its own set of videos, or like it's almost its own video series, which I could do later. But I just wanted to show you guys the unpowered splitters, so you can kind of get started, especially with making those screens and different things like that, but also for you to understand the concept of splitting to get more out of your mainframe system.